Hi, and welcome back to the Delivered Cost Workshop. And in this topic, we're going to talk about batch processing. Now, we've already been exposed to the concept of Armorous Raster Utility and what that toolbar is, in addition to the delivered cost modeling approach and how this is different than the classical approach. And before we step into actually using the model, I want to talk about one other topic here, and that is batch processing and exactly what batch processing is. Now, I alluded to this in the original introduction to the course, but batch processing is simply a different way of submitting a series of commands to an executable and running. Now, these commands I have built and this language I've built to expedite a lot of the modeling and actually store a logical series of steps so that people can look at it. And to highlight this, we're going to use the Stanislaus data set, and we're going to actually get at those data sets. Now, you should have already been able to download and install the Armorous Raster utility and the data sets themselves. But if you haven't, go in at this point and download those data sets. Refer back to, I believe that's topic number 1, the Armorous Raster utility tool, and get those data sets. Now, just as a reminder, we're using the Stanislaus example in the National Forest, and we're going to use data sets such as Tiger Road, NHD streams, and water bodies, where we've got an LMU for fishnet command, which isn't necessarily important related to this batch process, but will be important later on. And we've got a whole series of surfaces that give us an estimate of the existing basal area trees per acre and biomass, in addition to an elevation model. And in our simple example, we use those data sets to get at travel times, desired condition, revenue, costs, and income, and summaries. And those really represent inputs into our user form that we plugged in. Now, we need to think about those user inputs because that's basically what we're doing with this batch processing, is we're going to plug inputs into a series of commands. And we're going to do that in a series of text files that have a .bch extension, and we can combine a number of different raster surfaces and or vector processing and get to a final output. And the code looks something like this. In this case, we're looking to identify everything that's less than 165 square feet in order to get to a fire resilient condition, in which we're going to open up something like the soft basal area surface, the hardwood basal area surface, and the total above ground biomass and of each of those, and combine those together so that we can series of logical statements and get at those values, and then finally get to how much is on that landscape. Now, we're going to have a much simpler example that we're going to work through for this exercise that's associated with this topics, but in context, this is exactly what we're going to do. Now, there's a couple of key things to note here, that in between variables, in between for each one of the commands, they are semicolon separated. Each one of the commands are all in uppercase, so open raster is a command, arithmetic is a command, logic is a command, and the variables that are input into that command are semicolon, and they are encapsulated within a series of parentheses. That's about it in terms of the complexity of the syntax, and I'll show you in just a moment where you can find the syntax for each one of these commands. But what's really nice here is within this batch processing concept, we can build a whole series of smaller sets of commands and use those as inputs into larger commands. So we can combine our restoration areas that we were just looking at and use that as a batch file as an input and use it just as a raster dataset, similar to how we can use that batch file as a raster input in the table of context. And then finally, we can generate these numbers because remember, our overall emphasis here was to get at some numbers that we can then prioritize based off of using forces. But we could do all this within this batch context and summarize them all up to the LMUs in this case. Now, we're not going to go through that in this simple example, but in later examples, the more complex examples, we will step through that a little bit further. And that's in this last slide helps to illustrate just that point. We can run these analyses and generate those numbers so that it's a direct input into ForSysX. And so what does this actually look like? Well, let's go ahead and go into ArcMap, and let's go ahead and load up our Delivered Cost Workshop MXD. And when you do, you should see something similar to what you're seeing right here in front of you. All of our LMUs with a series of numbers behind them that you're going to populate. But the batch processing tool itself we can go into this little Go button once we've loaded it into our user interface, which, just to help remind everybody, we can go into Customize, and we can go to Commands. And as those commands are loading, we can then select the Go button from the general. Take just a second to read all the commands. There's a number of different commands built in here. And as soon as we can navigate to our raster utilities tab, to our general tab, our set of commands, and we can see there's batch processing. So we can dump that wherever we want on this toolbar. Since I already have it, I'm going to leave it where it is. But once we have it installed, we see we have this editor that comes up that allows you to helps you to perform the batch scripting. In this case, we can specify something like DEM. And what if we wanted to make a new output? So we'll call it JKL as an output equals arithmetic, and then we're going to have a parenthesis. And we're going to take our DEM and we're just going to multiply it by 2. And we use semicolons to separate it, and we click this ESRI multiply, and then we got to end our parenthesis. And the syntax is that simple. In this case, what we would do is multiply our digital elevation model, which is in meters, by 2. So you can see how we could do this, where we can convert this into feet as opposed to meters. Let's, instead of being 2, let's go 3.281, the conversion factor, 3.281 feet per meter. And now our DEM would be in feet. If we were to hit run, we'd generate a new function raster surface that comes to our table of contents. So it's really quite that simple. Now, what if we wanted to learn the syntax? You didn't know the syntax ahead of time. There's a nice little button that if you're highlighting the function, you can click on syntax. It'll give you an example of how you input that syntax. You can save these as text files, or you can even open up a text file and you can run that. You're not limited to just using this batch editor. You can actually go in and write a text file. And so in the upcoming assignment that you're going to be working through, it's going to ask you to combine the hardwood basal area and the softwood basal area for the Stanislaus, and then do a basic logical statement to find all areas that are greater than 165 square feet. So the way that we actually type this out is we type in basal area 1, something of that nature, equals our function open raster. Let's look at what open raster, what that syntax is. Click on the syntax button, and it says we need to set a output variable equal to this command open raster, and we just need to provide the raster path. Now that raster path can include a separate batch file, but we'll go back to this batch file. We've got open raster, and in this case I'm pointing to the location of my hardwood basal area. You'll have to point to a different location because it's going to be stored differently on your machine, but you're going to open up your raster, your softwood basal area. We're going to add an arithmetic function where we're going to add the hardwood and the softwood raster surfaces together. So we're going to use variable 1, semicolon, variable 2, ESRI raster plus, and then our final step is going to be create a variable called BAAG, and it's going to equal a logical function where we take BAA, which is the combination of B1 and B2, and the value 165, and it's going to find all cells that are greater than that. And the output's going to be a cell value of 1 for the case that that's true, or 0 if it's not true. And it's really that simple. We need to save this .bch file, and then when it's saved, we have a nice little tool here where we can load any BCH file directly into the table of contents. And what this is actually doing is running through all the different command steps and taking that last command step and adding it to the table of contents. So I'm just going to go ahead and load that in so we can see what this looks like, remembering that these are just a series of commands that we're storing. And we can see we've now processed all those commands, loaded those things in, and we now just have one BAAG raster surface. It doesn't truly exist on disk. It's a virtual surface. And what I'm going to do here is show that we can use it as a regular raster however we want. And we can define whatever values or whatever extremes we want, and we can set it, just as if it was a regular raster. We can hit OK, and when we hit when we check it to turn it on, we'll see that we'll have a series of zeros and ones across the entire area. All the light colored areas represent zeros, and all the darker maroon areas represent ones. And so I'm going to go ahead and turn some of these other values off so that we can see this a little closer. And we'll zoom down in and let it render. And as we can see here, there were no areas in this location that had a value greater than 165 square feet. If we were to click on any one of those cells, we can see, oh, I'm sorry, there are some areas. We can see that it's not rendering correctly. So let's go ahead and change this coloring. Instead of percent clip, let's go to standard deviations. And now we can see here are all the cells that are combined here. And this actually brings up an important point. ArcMap does a lot in terms of the displays for you, and you need to be conscientious of how it's rendering those statistics. When we were doing percent clip, the vast majority of these values fell within that 0 range, so you got a rendering that was looking at 0. When we went standard deviations, we had a bigger pull that we were getting at, and so we could actually get at those values. So it's important to remember that and actually look at what those cell values are. But this ends our little lecture on how to use batch processing, what batch processing is. And I challenge you to go through and look at all the different functionality and play with this for a little bit. Get familiar with batch processing. Look at the syntax that's associated with it. Check out something like gray level co-occurrence metrics. What does that mean? Look into clipping and doing zonal statistics. And with that, I'll leave it to you and look forward to talking to you over the next topic. Thank you much.